That's right. All right, moving on. This one I'll keep showing you the solutions, right? So instead of doing 5 and then 6, we'll start with 6. Probably a little bit easier that way. So,
Really?
yep, really. So what I want to do is I want to find the continuity of that function, right? So as I'm looking at this, I'm noting that I cannot put 4 in for x, right? Because that will give me a 0 in the denominator. So already I know x equals 4 is a point of discontinuity, since f of 4 just doesn't exist. In fact, you get the indeterminate form, 0 over 0. Right? And now, I also am noting that it's continuous everywhere else. That's the only issue. And so if you recall, if I were to graph this, here's 4. And what we're going to have is to the left of 4, it's going to look like negative 1. And to the right of 4, it's going to look like positive 1. Okay? And so the only question is, what type of discontinuity am I looking at? And so, of course, the type of discontinuity I'm looking at would be a jump discontinuity. Right? So we have a jump discontinuity because why? That's right. We have a jump discontinuity at 4. Since we have two limits, both which exist but they're different. Since the limit as x is going to 4 from the left is negative 1, which is not equal to the limit as x is going to 4 from the right, which is positive 1. Right? So that's that. So if we look at the tangent function, recall that the tangent is, that's right, sine over cosine. Right? So just like in the previous example, right, what values of x cannot go in the denominator? Well, we'll have discontinuities whenever cosine x equals 0. Right? For the same reason that the other function had discontinuity x equals 4. Right? So the question is, when is the cosine x equals 0? Yep, that's right. So it's pi over 2, 3 pi over 2, 5 pi over 2, negative pi over 2. So at x equals ... negative 3 pi over 2, pi over 2, 3 pi over 2, 5 pi over 2. Right? Those are all the zeros of the cosine. Right? And the reason those are discontinuity is because f of all of those values just doesn't exist. Right? It gets 0 in the denominator. Okay.
Daddy?
Furthermore, those are what are called infinite discontinuities. And if you recall, there are lots of those vertical asymptotes, and I'll show you up here. Yes, sweetie?
Are you going to need that microphone and talking?
Almost done. So tangent x, right? And so I'll make sure I'm in degree mode, radian mode rather. Enter. I'm going to hit zoom trig, which goes from negative 2 pi to positive 2 pi in both axes. So here's a tangent. You can see those vertical asymptotes, those infinite discontinuities. Right? And so hopefully you remember that's what the tangent looks like. Here's x equals pi over 2, infinite discontinuity, vertical asymptote. X equals negative pi over 2, another infinite discontinuity, vertical asymptote, etc., etc. Okay? So that'll do it for this chunk of questions. Let's move on to the more abstract ones. Okay? So moving forward, f of 2 equals 4, well, nothing, right? Right? That's a behavior at 2. That's a behavior around 2. And remember, what we're establishing is that those aren't necessarily the same things, right? Unless we know f is continuous at x equals 2, in which case the limit as x is going to 2 equals a function at 2, which would also be 4, right? There's your definition of continuity at 2. Okay? Narrate limits could not exist in one of two ways. Right? We have a jump discontinuity, right and left hand don't agree, or we have an infinite discontinuity, which looks like a vertical asymptote. Okay? Those are the two ways limits could not exist. How about this one? Two functions agree to a point. How about that and that? All right? Or to get more real, how about y1 equals, let's say, x plus 1 over x squared minus 1. And the other function is simplified version. right? And what's the difference between these two, y1 and y2? The first one, x cannot be plus or minus 1. The second one, x cannot be positive 1, right? So this guy here would have a hole at a removable discontinuity at -1. And this guy would have no hole at -1. In fact, it would go through the point -1, -1/2. Okay. So that's the only difference. Everywhere else they're the same, samesies. They agree at all but a point. All right, moving on. Example of a function, the f of c exists, but we have a point of discontinuity. That could look a number of different ways. So there's c. So we could have a limit that doesn't exist. Or we can even have something like a removable discontinuity as long as we have a value at that point. Okay. Or I guess we could even have a vertical asymptote and then kind of assign the function value of a particular value at that x value. Right. So that's what that could look like. Okay, I think that's it. Oh, lastly, Franny, what she's kind of thinking here is that the limit as x is going to 1 is the same as f at 1. All right. Well, what is that? That's continuity at a point. Right? That's what she's assuming. Okay, when the limit as x is going to 1 equals
I'm
f at
done.
1. Okay, are we all done, Mags? Say
Yeah.
bye-bye, everyone.
Bye-bye, everyone.
Study hard.
Study hard.
Bye-bye.
I can't even hear myself.